Like, I'm almost losing one.
And he didn't even collect the tuition.
Whose is that?
I know.
Is that Kat's?
Yeah, that's here.
What do you think? I've seen them time to read it a year ago. Watch here. I think we are on our way out.
What day sound?
It's pretty bad. Not at the speed that are happening. So let's all quit school and just hang out.
Yeah.
Until it happens.
Let's do it. So what happens?
All right, let's do it. Let me give you the rest of your instructions, and then I'm going to answer questions on your homework that you worked on. Okay? Kind of show you how to do some of the stuff. Yeah.
Where were we supposed to send the email?
To me.
To you? Okay. Yesterday or like?
I mean, it was yesterday, but I mean, I went around and looked, so.
Oh, I have it.
So I just need to check it out when you're done. I mean, you could send it to me. Some of you send it to me. That's okay. I just put it in a file on my email.
Okay.
So that I don't lose it. But you can always do your learning stuff. You just bring me the hard copy. You don't have to email it to me. But emailing it to me assures that it won't get lost between home and
I
here.
put mine on Google Classroom.
Yeah, and that's fine too.
I didn't even know. I don't know how to do it.
That's fine.
Okay.
The hard copy is really what I'd rather have.
Okay.
Okay, let's do this. You ended with 23. I'm going to go ahead and do number 28. This is 28 is a continuation of the same type of stuff you did last night with a little bit of extra. Y equals 4 cosine of 3t, and excuse me, that's x. X equals that. Y equals 4 sine of 3t. All right. So the first thing that you're supposed to do on this set, let me get a marker that works. First thing you're supposed to do is find what happens at time t being 0. So t is over time, what's happening? Really?
Wow.
Put the cap on and shake it.
Shake it.
Yeah, Kyle.
Brady, throw me the cap. Brady, throw me the cap.
Okay, so when t is 0, this is how you start all of your homework problems. In this case, t is going to be 0. 3 times 0 is 0. What is the x value at 0 degrees? Cosine is x. So what is the x value at 0 degrees? 1. 1 times 4 is 4. Okay. 3 times 0 is 0. What is the sine? The y value at 0 degrees? 0 times 4 is 0. So that was the first part, or what you're going to answer. Now you're going to do 2 of these problems. And these are going to be circles, basically. So at time t being 0, your point is at 4, 0. That's the first part of the question. The next question is, what is happening to the sine and the cosine? Are they increasing or decreasing? And in which direction are we going? Are we going clockwise or counterclockwise? So a good thing to do is just kind of plot a point, or maybe 2 points, and see what happens. So let's go ahead and do pi over 6, that's 30 degrees. When t is 30 degrees, what's 3 times 30?
90.
90. What is the x value at 90 degrees? 0 times 4 is 0. Okay? What is the y value at 90?
1.
1 times 4 is 4. Okay, so 1, 2, 3. So here we have this direction happening. So we're going counterclockwise. Now my question to you is this. And I'm not asking about x or y, this x or this y. I'm asking about cosine and sine. So as time increases, as t increases, what is happening to cosine? The cosine in this respect is in the x value. So look at my x values here. Did it increase or decrease? It decreased. And that's what you would say. The cosine is decreasing. What about here? When the sine value, that's going to be our y value. Did it increase or decrease? It increased as t increased. That's what it's going to be asking you, those types of things. So it does help to draw a couple points and label them, make sure you understand what's going on. And then you have to get rid of parameters. How do I get rid of cosine and sine? Anytime you have the same degree, if it's ones, then you can write them as cosine squared plus sine squared. That would be great. So if I squared both of these and added them together, I have x squared plus the y squared. So these two things squared added together, I get 16 cosine squared 3t plus 16 sine squared of 3t. Remember, this is just a position. The 3t is your degree. That's not being squared. So what do I have here? If I factor out a 16, what is cosine squared plus sine squared? 1. 16 times 1 is just 16. There is my rectangular equation. So we eliminated the parametric part, the t part. Again, the more you do, the more you see how it works together. That's why you have those solutions, yes?
You're doing that's not like that, where they're not the same.
They're going to be the same for tonight's.
Okay.
So when they're not the same, that was what you did last night.
Yeah.
You had different things. So the more of those you practice, and I can do some of the even ones today too, just to show you how those things work. I did make an extra test, so I'll give you a pre-test tomorrow. We can talk about it during class tomorrow, and then your test is Thursday. So we're going to continue. This is you're going to do 2 problems like this, where they're going to be a lot like this. And then you're going to do two problems like this. Let's do something simple. At the beginning of yesterday's assignment, it was really easy, right? You just had x, y, and t. You didn't have any trig functions. So what we're going to do here is we're going to work that backwards. Given the equation, and let me do, let's just do something easy. I'll make this up. 1, 3, and 4, -1. Given 2 points on a line that is graphed. First of all, you ought to be able to come up with the equation of that line, right? You should be able to do that. Finding the slope, finding the y-intercept, put it in slope-intercept form. You all should be able to do that. What I want is the parametric equations, and they take this form. This is something you should know. X equals, x sub 1 is the first x of the first coordinate, plus t. Y equals y sub 1 plus the slope times t. And once you fill this information in, you then have parametric equations. So x is easy. 1 plus t. Y is going to be a little bit more difficult. Y sub 1 is 3. What's the slope between those 2 points? How do I find slope between 2 points? Pre-calculus students.
He uses a slope formula.
Isn't it 1 minus 4 over 3 plus 1 because it's like a -1?
How about the y values?
Oh, over the...
Changing the y's over the changes of the x's. So -1 minus 3 is -4. 4 minus 1 is 3. So -4 thirds t.
That's sort of right. That's sort of right.
You can't be sort of right in math. You gotta be all right. That's all you have to do. Here's another example. What if I just said the slope is 2 and here's a point, -3, 5? What would be my parametric equations? Somebody.
X is -3 plus t, and then y is 5 plus 2t.
Yep. Okay. So if I were to graph that point with that slope and draw the line, and then eliminate the parameter t here, put it in slope-intercept form, it'd be the exact same thing. Okay, so here you're just working backwards, given information. If I gave you a graph of a line, Pick 2 points on it, find the slope, plug it into the information.
Why is this easier than last night?
Why?
Why is this
We're not
easier
done.
than last night?
You'll have 2 problems like that one, 2 problems like this, and a couple problems like this. This is number 34. Given the rectangular equation, give me the parametric equations that you started with. So this is backwards from what you did last night. Hopefully you kind of figure it out because you've already done it one way, or at least hopefully you worked on it. So here's a generic ellipse. Notice I didn't put any values for A and B. This is just the generic part for every value of A and B equal to 1. I want to know what we started with to get that. So first of all, what do you notice up here that is hopefully something that you recognize? Something simple. What is, yeah, what'd you say?
A squared plus B squared equals C squared.
Oh, not that part, The top part, x squared plus y squared. Anytime you see that, you should be like, oh, cosine squared plus sine squared. That should be familiar to you. Not that it's necessarily exactly the way it's written up there, but you should notice that we have some squares and we have x's and y's, so that's a good thing. So I want to change this into trigonometry stuff. So if I just said cosine squared of t plus sine squared of t equals 1, that is true, right?
Yeah.
But I need to make this look like that somehow. So if I just replace the cosine with the x here, and the sine with the y there, I have this. But these two are not the same. Okay? Because this does not equal 1. Without the a squared and the b squared, it does equal 1. So it's great that you substituted those values in, but that does not equal 1. I can't just take cosine squared of t and divide it by a squared. I can't do something to the bottom without doing it to the top. Those would cancel out, and then I'd have that equal to 1, right? Okay? This is now equal to what I have there. So now my question is, and what you have to start with is what is your x and what is your y? This is what you started with in your homework yesterday, just like what we have right here. So what is in this x position over here?
A squared cosine squared.
A squared cosine squared. So the x squared is equal to a squared cosine squared of t. So what is x?
A cosine
What?
A cosine t.
Yeah. What do you think y is going to be? Alright, so what is happening is here, you gotta start working with those reference Pythagorean theorem identities that you have and try to make it so everything works out right. What you write over here has to be true. I just couldn't take cosine squared t over a squared, sine squared t over b squared, instead of equal to 1 because it's really not equal to 1. Only cosine squared plus sine squared equals 1. Same thing with tangent squared plus 1 equals secant squared. You're going to use that in your problem, one of your problems tonight, but you got to make it so it is actually equal to what it says it's equal to. You just can't just slap it up there. And this is just an example of how you had to manipulate the equation that you knew so it would work. And that's all you've been doing. Sometimes you had to multiply both sides by r to get r squared, and you had to complete the square. That's on the test. One of those is on the test. Already told you. Okay? We'll cover that again tomorrow. Alright, so what I want to do now, your assignment, and then we'll answer questions on last night's homework. I'm going to record that as well. Yeah?
For the one before that, how come the first one doesn't have 2t?
Here?
Yeah.
Because the form doesn't take on the slope for this part. Okay?
Okay.
That's just how it works out. If you were to eliminate the t and write it in the correct equation, the slope doesn't fit into that position.
Okay.
Okay. What was I going to say? What's the page number of that assignment? Is it 569. Tonight you're going to do, you did up to 23, you're going to do 25 to 35 odds. Okay, so you have the solutions to these problems. You need to be trying to figure out what they're doing in those problems. Otherwise, you're getting nothing out of this. Okay? Now, I'll go ahead and answer some questions on the homework. We'll get this recorded. That way, that'll be helpful to those people who need to rewatch it for next year's students. Those of you who really struggled with this should help you out. All right, so where are we at? What questions do you have? Any questions, or did it all make sense to you?
Number 13.
13. That seems to be a common question. Awesome. So between 0 and pi, so the first thing you're supposed to do is make a chart between 0 and pi. So t and then graph it what you get. So we're going to start at 0. Y value at 0 degrees on your unit circle. What's the y value? 0 times 2 is 0. X value at 0 degrees? 1. 1 times 2 is 2. Excellent. So let's just graph this stuff from 0 to pi. 0 to 2, not 2, 2. This even. All right, now pi over 6 is 30 degrees. What is my y value at 30 degrees? 1/2 times 2 is 1. Cosine, the x value. Square root of 3 over 2 times 2 is just square root of 3, 1.7. So at 1, we're at 1.7. Okay, keep going. Pi over 4. Everybody knows those values. What are they? Square root of 2 over 2 times 2 is radical 2. Times 2 is radical 2. 1.4, 1.4. So about right there. And pi over 3. 60 degrees. The y value is 60 degrees. Square root of 3 over 2 times 2 is the square root of 3. Notice what we have here. X value, 1/2 times 2 is 1. And this became symmetrical. Now pi over 2, 90 degrees. Y value of 90.
1.
It's 2. 2 times 1 is 2. X value at 90. 0 times 2 is 0. 2, 0. So this is that part right there.
The whole it being like 2 or x equals 2 sign confuses me because I want to say that like that's for the x or for the y spot instead of the x spot. You know what I mean? Like in the
Right.
Yeah, that confused me really bad right there.
Yeah, that's why you don't look at this until you're done.
Okay.
Okay. All right. So now we have to go to pi. So I'm just going to go 2 pi over 3 just to see what's happening, and then we'll kind of assume some things. So at 120 degrees, what is the y value at 120? 60 degree reference. Radical 3 over 2 times 2 is radical 3. And that's what we have here. And the x value?
1/2.
Negative 1/2 times 2 is negative 1. So at radical 3, 1.7, we are at negative 1. So this is coming like this. I'm assuming it's going to come down to 2, so let's just verify that. It goes all the way to pi, so my next one I'm just going to do pi. Y value at pi.
Negative
Y value at pi.
0.
0. X value at pi.
-1.
Negative 1 times 2 is negative 2, and we are right there. So, and that's all we're going. We're only going from 0 to pi. So we're stopping there. Now, this is 13. Now we need to eliminate our t's, our trig functions. Again, we have sine and cosine. So if we square both of them, we'll get sine squared and cosine squared, right? And also 4 is in front of them. So if I square everything and add the two equations together, I get x squared plus y squared equals 4 sine squared of t. Notice the t didn't get squared, that's just your degree. Plus cosine, 4 cosine squared of t. Factor out the 4. X squared plus y squared equals 4 times 1. So that would be, this would be a circle. So I don't have a circle up here. What should I say about my parameters? Huh?
Circle.
That it's x is greater than or equal to 0.
Yes, x is greater than or equal to 0. Good. That was 13. Okay, just repetition, seeing it. Other questions? Got 9 minutes.
Can you just do it, just another one? I don't know, just go to the next one. I'm just trying to pick it. Well, the only thing I'm having trouble with is the chart was with pies.
This?
I'm just slow at it. Yeah, I got it, I'm just slow at it.
Yeah, alright, we'll just do another one.
Yeah.
Okay? Pick another problem. 15.
17.
15.
22.
17.
We'll do 15. If we have time, we'll do 17.
Right.
Alright, 15. X equals the sine squared of t. Y equals the sine to the 4th t. Oh, there's no cosines there. I guess we can't do it.
No, we can't.
No, we can?
No,
Okay, we'll do it. We'll try. I'm not a very smart guy, so I may need your help. So, do we have anything about t?
Yeah, square.
I mean, is there any parameters I didn't write down? Like 0 to pi, or was it 0 to 2? I think it's 0 to 2 pi. May just be 0 to pi or 2. Somebody check that for me real quick. We'll just get started. So when at 0 degrees, what's the y value of 0 degrees? 0. 0 squared is 0. 0 to the 4th is still 0. Alright, pi over 6, 30 degrees. What's the y value of 30? 1/2 squared is 1/4. 1/2 to the 4th is 1/2 to the 4th. Thank you, 1/16. Alright, so I'm gonna make this a little bit larger here. So 1/4, we're at 1/16. Okay, what about pi over 4?
Wait, why? Oh, wait. It's 4 less than. Never mind.
What?
I was gonna ask why it wasn't on the line, but then I was like, yeah, the 1/4.
Okay. Radical 2 over 2 squared is what?
Wait, what?
Radical 2 over 2 squared.
2. Oh, wait, yeah, 2.
1. No?
2.4.
I can't. I'm sick. Don't make me mad. Square root of 2. No.
What happens when you square square root?
1/2.
This way.
Yeah, that becomes 2 over 4, which is 1/2. And then to the 4th, so 1/2 times 1/2. 1/4. So 1/2, we are at 1/4. Okay, pi over 3. What is y value of pi over 3? 60 degrees. Radical 3 over 2 squared is 3 over 4. And 3/4 times 3/4. Why am I just taking this and squaring it? Why am I doing that? To get the y value. Because isn't that just the square of this? Okay, so 3/4 squared is 9/16. So 3/4, we're at 9/16, just over half. Pi over 2. What was there anything in the book about the parameters? No? Okay, pi over 2. 90 degrees. What's y at 90? 1 squared is 1. 1 to the 4th is 1. Woohoo! There we go. Look at that. We better check 120. 60 degree reference. What is y? Radical 3 over 2. Squared is, oh, 3 over 4. And then we get that exact same thing. Oh, so what's happening? Just going back and forth, oscillating back and forth. Alright, so that's part A. Just plugging in the values. That's why there's no parameters. It just keeps going as its own. Next part, you gotta get rid of your sine function. What do you think we should do?
IDK.
Take out a sign. X is greater than or equal to 0, but
Wait
yeah.
a second. Can I get sine to the fourth from this? If I do something? If I square both sides, let's say x squared equals sine to the fourth t, right? Well, if sine to the fourth t equals x squared, don't I have y equals x squared? That wasn't that hard, was it? Obviously, when you see it, you're like, oh yeah, well duh. But you just have to try some things and work some things out. Every problem's a little bit different. It takes practice. That's like me saying, okay, let's just add 2 plus 7, 5 plus 3, 1 plus 9, 5 plus 1, 4 plus 1. And then you go home and you look at your homework assignment and it's 85 plus 93. Still adding, except you have a little bit different. It's not possible to show you everything. Okay? Alright, we got time? 17? Yes or no?
Yes.
Who said nah?
I got Corey.
Yeah.
Okay.
Watch this. Do you want me to do this part?
Yeah.
Or can you do that?
I can. I'm just slow at it.
Okay.
It just takes time.
But can you?
I
Anybody
think-
else want to see it? I can do it right now. Say so.
Yes, do it.
Okay.
Go ahead.
Okay, this one doesn't have any parameters, I don't think, so 0. X value is 0. 1. What is the y value? 2 times 0 is 0. Cosine at 0. X at 0. Right? It's a double angle. Might want to look at your reference sheet for double angle. 1, 1. Okay? Alright, so pi over 6, 30 degrees. X at 30. 2 times 30 is 60. What's the x value? 60. Yeah. This is 0.8. At 0.8, we're at 1/2.
This is the lightest
What?
one. Cosine
I think it's 0.8, isn't it? That was right. Okay. Pi over 4. Yeah. I don't know if I did that right. And then 2 times 45. 90. What's the x value of 90?
0.
0.
Right, 2 over 2. So we are at, what is that? 0.7 and 0. Can I write this problem down right? And pi over 3. 60 degrees, what's your x value? 60? What's the y?
3 pi over 2.
2 times 60 is 120, so what is the x value of 120?
Mmm.
1/2 and 0.7. Something's wrong here. What did we do wrong? Did we go too fast? Oh, thank you.
Yeah.
Negative. That's negative 1/2, right? Wait, 60.
No, it's negative.
This is negative over there. Thank you. That's down here. So now you see what's going to happen here as I keep going. Okay. Not a circle. Okay, so here's what we're looking at here. What do you know about cosine of 2t on your reference sheet? It's a double angle, so what do you know about double angles? That's one of them. Okay? X is the cosine of t. Cosine of 2t is what? See, every problem is just a little bit different what you're doing. You just had to recognize you had a double angle formula there. Otherwise you couldn't do it. Alright. See ya.
Sweet.
Yeah.